Hello guys, so in this video I'm going to explain you about stack memory and the heap memory in Java. So first we will go through the key difference between stack and heap. The first is stack memory. So where it is allocated, like memory allocated for each thread, and for heap memory the shared memory area for all objects created during runtime. So what gets stored inside stack memory? So local variables, methods call, and in heap memory objects, array, and any dynamic allocated data. And for size, so much smaller than the heap. For heap memory can be larger and can grow as needed, so depending upon the system available memory. Fourth one is life cycle. So automatically manage. So memory is cleared when the method get call end. And heap memory, data remain in memory until the garbage collected. Okay. So in stack memory the acts fast to access, and heap memory slower than the stack memory. Real life analogy. So stack is like a stack of a plate in a restaurant. Each plate is removed once its job is done. That is method execution. And for heap memory, the heap is like the warehouse for the all long-term stored goods like object. Item can be stay there for as long as they needed by the application. So it is like when you are up your services, then whatever the object you are creating, that will stay till your service is up. When it will go down, your all the heap memory get destroyed. So it is not applicable for stack. Stack memory is executed when the method is called, and when method get end, the stack memory get destroyed. Okay. So what is first we will learn the stack memory. So what is stack memory? The stack memory is a part of memory where the method specific data is stored during execution. So it operates on the LIFO, that is last in first out principle. It is automatically managed, created when the method is called, and cleared when the method is finishes. So what is stored in a stack memory? So first I will go through the theory, then I will explain you with a real-time example. Okay. So first is local variable of the method. Parameter passed to the method, return address, intermediate calculation, primitive data types, reference to the object. Okay. So first I will go with the local variables. So local variables are stored in a stack memory like here. So these are the local variables: int num1 10, int num1 20, and int result, and this sum and this double result. So these are the local variables that are stored inside stack memory. So here is mentioned that variable declared inside the method, that is num1 sum double result, are stored in a stack frame for that method. This variable exists only for the lifetime of the method, but it is saying that this variable is exist till the method get executed. After the method get completed, so this will not exist. So second is parameter passed to the method, means whatever the parameter, that is num1 num2, are passed to this method, so that are remain inside stack memory. So argument passed to the method, that is num1 and num2, passed to the add and stored in a stack frame for that method. The parameter acts as the input value for the method. then return address, like this will also stored in a stack memory. So he's saying that each stack frame contains a return address that tells a JVM where to continue execution after the method call completes. For example, add return control to the line in a main where it is called. So it return the control to the main where it is called to continue the flow, and double value return the control to the line in add where it is called. So this double method return to this add method where it is called. And there is intermediate calculation. So whatever the calculation having over here, so it gets stored in a stack for a time being till the method get execute. Like temporary result are commuted and stored in a stack frame. This calculation exists only during the execution of the method. Okay, don't worry. I will at the end we will go through the example that how this stack memory works while executing code. So the primitive data types also stored in a stack memory, that is primitive variables declared inside the method are stored directly in a stack. Example, int, float, character, etc. Reference to the object. If 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 a method has a reference to the object, then reference is stored in a stack. The actual object is resides in a heap memory. I will explain you. So this is the stack frame class. This is the reference of this object. So by using new keywords, I am creating this object. Okay, but when I using new keyword for a stack frame example, so this class get stored in a heap memory, and this is a reference I am using to address this stack frame in. This is a reference variable. It points to the heap memory where it is located. The stack example is located. So this will stored in a stack memory. Okay, so I will go through this example. This is one example. From this you will get clear idea. Okay, so now I will explain you with real-time example that how the actual stack memory works. So before execution, this stack is empty, correct? So when this main method gets start, then one frame is added in a stack like this. Then cook method starts. Then for cook method, and there is new frame get added at the top of the main like this. Now this stack contain a 2 frame. So after this it will call the serve soup. For serve soup method, it will create another frame at the top of the stack. Now this stack contain a 3 frame. After that it will call the serve salad. So for serve salad method, it will create a 1 frame at the top of the stack. So now the stack contain a 4 frame. Now this serve salad get ends. After this, as soon as it get end, then this is come out from the stack. Now this frame contain 3. Then it again come to the serve soup. When this method end, then it come out of the stack. Now this frame contain 2. Again, after this completion, it again back came to the cook dish. After this, it will, after completion of this cook dish method, it is came out from the stack. Now this contain only one main method. So after this main method, so it will also came after this completion of this main method, it is also came out from the stack. So stack get empty. So this is a this is the stack memory working. So in short stack memory is nothing but the temporary storage for individual thread. So so this is a diagram. Okay. So for every method, this is for main method, this is for serve soup, this is for second method, this is third method, this is fourth method, this is fifth method. So whatever the method inside, so it get pop out after completion, at the end it get empty. So this is a stack memory diagram. For every method there is only, they are creating a new frame like this. Now we will learn the heap memory. So why there is a need of heap memory? The stack memory is limited and only stores a local variable. Method called data reference. For the data that needed to persist beyond the method call, like object, so Java uses heap memory just to store the objects by using the new keyword. That object are stored inside heap memory. So what can heap stores? So all instances of the class are stored in a heap memory. Okay. Also the array are also object in Java are stored in a heap memory. So yeah, so don't worry, I will explain you with a real-time example. So this is a book class. They are having instance variable, constructor, and from in main method we are creating the object of book. So this book is a reference, and this is the object will created inside heap. So that's what he's saying, that all instance of classes are stored in a heap memory. So this book object will stored in a heap memory, and this book object are stored in a heap memory, and this book 1 and book 2 are stored inside stack memory. So yeah, so heap memory is used to store the object and instance variable created during the execution of Java program. So it is shared memory area that can be accessible all threads in a program. So this is very important. It is shared memory area that can be accessible by all the threads in program. So this is not a thread safe. Okay. So there is a point. So key points of heap memory. So first is stored object. So any object created using the new is stored in a heap memory. Okay. So that one I have explained you in this example. Now this is very important, the garbage collector. The unused objects are automatically removed from the garbage collector. So you will ask question, then what is unused object? So unused object, like the object is having no more reference, overwriting the reference, or object are you going out of scope. Okay. So first I will go with the this no more scope. So no more scope, I can say So this is no more reference. So no more reference. So here is the example class. So in main method we are creating this object. So this object will store inside heap memory, and this is a reference. This str1 is pointing to this object which is present in a heap memory. Now when you declare this str equals to null, then now this is pointing to nothing. Okay, so this pointing to nothing. So there is no reference pointing to the hello, so it become unreachable and eligible for garbage collector. Okay, because these objects are created in a heap, there is no any refer pointing to this object, so this is eligible for garbage collection. Okay, now second one is overwriting the reference. So this is example for overwriting. So we are creating this object. So this Java object, so this object will store in a heap. So str is pointing to this object that present in a heap, but using the same reference we are creating the new object, that is Python. So now this str pointing to nothing because this is overridden by this Python. So now this Java object is eligible for garbage collector to remove. Okay, then this is object going out of scope. So object going out of scope, we can say that. So this is a create method. It's a create object. When we call this method, we are creating this object. That is, this object is stored inside heap memory, and this is a reference which are pointing to this object, and this is stored in a stack memory. So the scope object is accessible within this method. So this object is only accessible within this method only. Okay, so when this method get completed, and after this method, after the create object finishes, the local variable is go out of scope. Means after this method get completed, so there is no use of this object. So garbage collector will remove this object. So this is eligible for garbage collector to remove. Now last one is the global access. Object is in a heap can accessed by any thread through a reference. So yeah, so this is all about heap memory. So let me summarize the thing. So first is stack memory. So stack memory is nothing but stack memory is a part of memory that where method specific data are stored. It operates on a last in first out principle. We store the local variables, parameter passed to the method, return address, intermediate calculation, primitive data types, and reference to the object. Okay, so it stored the reference of the object. An object, actual object are stored in a heap memory. So heap memory is nothing but the all instance of classes are stored inside heap memory. So whenever we are creating object using new keyword, then object is stored in a heap memory, and the garbage is collected whenever this object is not in use. Means no one reference is pointing to that object, then that is eligible for garbage collection. And while working, when you do our service up, then whatever the object are stored inside heap, that will last till our service gets down. So that is the difference between heap and stack memory. So stacked memory is like temporary storage, and heap memory is like long lasting storage.